So here we are with chapter 5, number 24. And it reads, a 23-kilogram child goes down a straight slide inclined 38 degrees above horizontal. The child is acted on by his weight, the normal force from the slide, and kinetic friction. Part A asks, draw a free body diagram of the child. Part B asks, how large is the normal force of the slide on the child? So here we've got a picture of our child hanging out on a slide, so we can draw the free body diagram for this kid. Now, because the kid is on a slide that is tilted, what we're going to do is we're going to tilt our axes to match the incline of the slide. So when we do that, we know that the weight needs to always go straight down. There's our weight. The normal force is always perpendicular to the surface. They also then say that there is kinetic friction. So we've got the force of friction going this way. Okay, because they're going down the hill, so friction goes up the hill. AP test, this would be a good free body diagram. But for us to solve, we need to break it up into components. So we got is, this would be the x component of the weight, we'll call that W sub x, and this would be the y component of the weight, W sub y. So this opens up a pretty good thing to talk about in terms of what is actually going on here. Because we need to look at some bits and pieces. This angle is 38 degrees. If this is a right triangle, then we know that this is some angle that is 90 minus 38 degrees. We'll call it angle phi. If we then drew another triangle this way, so that we had another right angle right here, this would be also our 38 degrees right here. It's kind of hard to see. Let's see if I can just kind of put it in there a little easier. So 38 degrees is going to be that angle as well. So when you look at this now, you'll see that the x component becomes the y, it becomes the opposite side of our triangle. And the y component is now the adjacent side of our triangle. Typically, we're used to the x component being the adjacent side and the y component being the opposite side. But now when we tilt things, it throws things off a little bit. We flip those trig functions. So because of that, this is really what happened. We need to pay attention to this now, what sides are what. So when we go to part B, we can solve the problem. So part B asks, again, how large is that normal force acting on the child? So if we do the sum of the forces in the y is equal to ma sub y, the first thing we'll take care of is the fact that the acceleration in the y direction is equal to 0. The kid's sliding down the hill, that's the x direction, so obviously never seen anyone sliding down a hill and accelerate vertically. So we're going to make that 0. And if that's the case, we've got that the normal force then minus the y component of the weight is going to be equal to 0. Well, the normal force is equal to m times g times the cosine of 38 degrees. Plugging in everything we know, the kid is a 23 Newton fella, and then we have gravity is equal to 10, and then cosine of 38. We get then that the normal force is equal to 181 newtons. So that's that. That is chapter 5, number 24.